let's jump into our round robin scheduling algorithm in terms of the coding. So let's go through the code and discuss step by step, pointing on each function that is important here and each line of the code that represents everything. So okay, now first of all, I defined two constants. This is max processes and time quantum. So max processes represents the maximum number of processes which the system can handle, and time quantum, which represents the time quantum used in a round robin, as we mentioned earlier. And I assigned the number 2. So like in this amount of time, each process should be completed. So that's like a given time. This is preemptive, and I assign 10 just like in general, just it should be like 10 processes. And next, it is now to create the structure named process, and it has so I initialize these values like process ID, burst time, and remaining burst time. So like burst time, like as we said earlier, it represents the time required by the process to complete its execution, and remaining burst time represents the remaining time required by the process to complete its execution. So the like basic values, the like basic variables values that we're giving here. And next, this is the important part of our code. This is the function round robin, which implements the round robin scheduling algorithm itself. And it takes, like, let's discuss here. So it takes an array of process structures, which structures the processes, and the number of processes which we take as an input. So here, like remaining processes, it's like represents number of processes that are like yet to be executed. Next, we have like current time. We assign it to 0. It represents the current time of the system, and it's completed. We also assign it to 0. So complete is like array, constantly check which processes have completed their execution. So we're like holding some track of checking on it. And next, it's now time to open our loops. So we're opening the braces for while loop, like which continues until all processes have completed their execution. And here we have like nested loop, and inside we have inner loop 4, which deals with iterating through each process in a processes array. And then there comes the conditionals. Like here it checks if for example, like if the current process has like a remaining burst time. Next we are having all the conditions for that. So if it is remaining burst time, for example, is greater than the time quantum, it executes the process for that time quantum, and otherwise it completes the process. And then it updates the current time, like according to that. And if the process completes, it marks it is completed in a completed array, and it's going to decrement. And then like all these things are checked when every condition is done. Then it is printing the number of the process that is executing and the current time for that specific process. Now, as we implemented our round robin function, we are calling that in our main function. So what is happening in our main function? So we are creating the process, like declaring an array process of these processes, like this array of processes of the process structures, to hold the information of all the processes that we entered. and we are requesting to enter the number of process, and we actually enter that, and then we like prompt to enter the burst time for each process. And as we see, like we implemented here our loop, so like prompts used to enter the burst time and for each process. And so it's like then it reads the burst time of each processes and sets the process ID and initialize the remaining burst time to the burst time of the process. That's what's happening here. And then we are like calling our round robin method here, and then we're returning 0 as the end of the main function. So basically that's how it works. Now let's see, for example, how it is run. For example, it is prompting us to enter the number of processes. So for example, let's enter here like 5, and like percent, like we're giving the percent for each of them. For example, 2, 5, 6, 3, 3. Let's see here, and it actually shows the current time for each. It's like working here. So for example, it's 4, it's completed, so we see that process 1 is never accurate here because it's already completed, because I initialized that time quantum is 2 for our round robin algorithm. So therefore the process 1 is like absolutely completed, and we don't, so our queue doesn't save the place for it. So for example, if process 2 is actually its burst time is greater than the time quantum, so we basically see it occurring like many times, in terms of that it's still having a remaining time. And here for example, when the current time for the process 2 is 17, so it's like basically in terms of the coding, it now it's already completed. So for example, that's it actually already shows the way how the round robin is working.